Hi, this is the Science Chef. In this video, we'll be learning how to calculate the relative atomic mass of an element based on the relative abundances of its isotopes. Don't leave this channel and we'll be right back. In our last tutorial on isotopy, we learned that all elements are isotopic mixtures, which means that all elements are made up of isotopes. And this explains why the relative atomic masses of elements are not whole numbers. If you'd like to learn more about the concept of isotopy, check the link in the description. As we learned in that tutorial, relative abundance of an isotope is the proportion of that isotope that is present in a given sample of an element, and it can be expressed as a percentage or decimal or ratio or fraction. We will use this knowledge to calculate the relative atomic masses of elements as will be seen in our example. So let's consider an element X that has two isotopes, isotope A and isotope B, with relative abundances of A% and B% respectively, and mass numbers M and N respectively. Then its relative atomic mass can be calculated thus: REM of X will be equal to the sum of the products of the relative abundances and the atomic masses or mass numbers of isotopes A and B as shown on the screen. The ellipsis, that is, the three dots, shows that for an element that has more than two isotopes, we will just add the products of the relative abundances and mass numbers of its extra isotopes to the equation. This equation also shows that the relative atomic mass of an element is a weighted average of the masses of all its isotopes. Let's now see how to apply the equation in determining the relative atomic mass of an element when the relative abundances and mass numbers of its isotopes are given, and how to determine the relative abundances of the isotopes of an element when their mass numbers and the relative atomic mass of the element are given. Example 1. An element W has three isotopes, W30, W31, and W32, with relative abundances of 60%, 30%, and 10% respectively. Calculate the relative atomic mass of W. In example 1, we are given the percentage relative abundances and the atomic masses or mass numbers of the isotopes of W, and asked to calculate its relative atomic mass. To solve this problem, we will write out the given parameters and then substitute them into the REM formula as shown. So from the question, we are given the isotopes W30, W31, and W32. The relative abundances of the isotopes are given as 60% isotope W30, 30% for isotope W31, and 10% for isotope W32. Their mass or atomic numbers will be 30 for W30, 31 for W31, and 32 for W32. So we are going to substitute these values into the REM formula for W, which is So substitute these values into the RAM formula for W. This will give us So as we stated earlier, that the relative atomic masses of elements are not whole numbers because elements are isotopic mixtures. So they can see why that is 30.5. Another thing you should note is that RAM has no unit, so you don't need to add any unit here. One thing you should note here is that before you start your calculations, endeavor to ensure that the sum of the relative percentage abundances is equal to 100%. That is, if they are expressed in percentage, make sure that the sum of the relative abundances of the isotopes equal 100%. If not, it means that something is missing and needs to be accounted for. Example 2. An element X exists in 3 isotopic forms in the ratio 2 to 3 to 4. If the isotopes have the atomic masses as 29, 30, and 31 respectively, calculate the relative atomic mass of element X. In example 2, the relative abundances of the isotopes of X are given as a ratio. We are also given the atomic masses of the isotopes and asked to calculate the relative atomic mass of X. As usual, we will first write out the parameters provided, after which we will convert the ratio of the isotopes to fractions and then substitute the atomic masses and the fractions into the RAM formula as shown. Given, we are given 3 isotopes of X. Let's call isotope A, isotope B, and isotope C. So let's call them isotope A, B, and C. And the ratio of A to B to C is 2 to 3 to 4, while the mass numbers of A, B, and C are 29, 30, and 31. So the next thing we'll do is to find the sum of ratio. This is what 2 plus 3 plus 4. That gives us 9. Okay. Next we convert the ratio of each of them into fractions, starting with isotope A. The next thing we will do is to substitute these values into the RAM formula for X, which is Note that we add up the fractions of the abundances of isotopes A, B, and C. It will give us one whole number, which means that everything has been accounted for. Substituting these values into the equation above, we'll obtain RAM of X will be equal to what? Example 3. An element Y is composed of two naturally occurring isotopes, Y9 and Y10. If the relative atomic mass of Y is 9.68, determine the percentage abundance of each isotope. This example is quite different from the first two because we are given the relative atomic mass of Y and the mass numbers of its isotopes and asked to determine the percentage abundance of each isotope. So to do that, we'll have to assign the percentage abundance of one of the isotopes as x over 100 and the other as 100 minus x over 100. Then substitute the given parameters into the RAM formula and then solve for x as shown. We are given isotope Y9 and isotope Y10. We're also given the RAM of Y to be 9.68. Since we are asked to find or determine the percentage abundance of these isotopes, we are going to assign unknown values as their relative abundance. So we are doing this because since the element is made up of only two isotopes, it means that some of the percentage abundances must be equal to 100%. So if one is x, then the other one is going to be 100 minus x percent. So if we substitute these values into the RAM for y, RAM for y will be equal to So substituting the values, this will give us 9.68 equals to x over 100 times 9 over 1 plus 100 minus x over 100 times 10 over 1. But remember, that's not the final answer. You were told to calculate percentage abundance. Remember, we assigned the percentage abundance of Y9 as x over 100. So if you leave your answer as just x, then it is wrong. The answer must be expressed as a percentage. You can as well substitute x into this expression, and that will be 100 minus 32 all over 100. That will be 68 over 100, which is the same thing as 68%. If you obtained any value from this video, kindly drop a comment, like and share this video, and subscribe to our channel to encourage us to do more videos like this. Stay safe till I see you when I'll see you.